This is going to be the hardest part of science probably this morning, but we'll get through it easily, I hope, and try to look at evolution's greatest problem. Now, I know every one of you, I've already heard from two ladies this morning who think they know what evolution's greatest problem is, and they were correct in what they were saying in evolution's greatest problem. From a science point of view, I thought I knew what evolution's greatest problem was after a book was published called Darwin Devolves. And I've got that book over there on the table. Michael Behe just does a really great job. He's been researching this for a long time. And so he talks about evolution's greatest problem. And then F. Smith wrote a book that came out last year, and he kind of refers to evolution's greatest problem. So I don't know if it's mutation and natural selection that's the greatest problem or the origin of sex. But we're going to look at both of them this morning. Is that okay? Say yes? Yes. All right, so we'll see what's going on with all of that. Now, when Darwin started this thing about evolution a long time ago, the middle 1800s, he really, they didn't know anything about science. They didn't have any kind of technology to look at anything in detail. It was strictly just based on observation. And so, but it's hung on. It has hung on for a long, long period of time. It's only been recently, now that we can look at DNA and sequence it, we can actually know what's going on here. And so, I think it's going to turn evolution upside down, and they're going to have to give it up. I'm hoping that's what's going to have to happen. And so I want to show you a little bit about that this morning. The emphasis in evolution is common descent. We all came from a common ancestor, and you all know that. That's what their main emphasis is. And they can hold on to that because they look at similarities among all organisms. For instance, humans and chimps, we have similar body plans. We're kind of a little bit upright. We have 2 legs, 2 arms. We have a similar body plans. And so they key on that, what you can see. They key on what we can see and say, okay, we have a common ancestor because we look the same. That's what evolution has been doing all along. But you know what? Just because we look the same, it doesn't explain how an ancestor got the trait in the first place. Doesn't explain that. And it doesn't explain how the lineages came to differ over time. And so they will tell us this because we can kind of understand that. But they never mention these kind of things to us. And so that's how evolution works. They keep it simple, just keep it really simple, and just tell you something that you can visually see, and everything is okay. So that's how evolution works. Well, this is their story, and this is their story in one slide. There are mutations, some are bad and some are beneficial. That's true. I can check that off. That is true. That's what's going on. They also say natural selection occurs. There's this competition in nature, and one organism is going to have a little bit more advantage over others in reproducing and surviving, and so natural selection occurs. We even see all of these TV shows that show nature, the nature shows on TV, and we can see natural selection occurring. So yes, natural selection occurs. And so evolution uses some things that are true. And then they say selection, if you just repeat it over and over again, it's going to lead to a new species. And in the process, it's going to build up all of these wonderful structures of life. Well, I'll put a comma up there. That's true. That's true. But can they show that? No, they cannot show that. In fact, we know things do not accumulate over time. We know that right now. So, that not what they can actually show is not back to mutations in natural selection. And now we can test for that. So it's really good time to be in biology to really set evolution where it needs to be. Okay? So I'm going to look at several organisms this morning, help you understand genetics and mutation and natural selection a little bit. And then at the end, we're going to take a quick look at the origin of sex, and then we'll be done. All right. You like the bears? Yeah, this is the polar bear, Ursus maritimus. That is this genus species name. World's largest land carnivore. 25,000 of these guys in number, solitary. They spend their whole life by themselves except when they mate. And then they're up there in the northern part of the North America and in those regions. And so up there in the bitter colds or up there in the frigid ocean waters, that's where they live. Closely related to the brown bear. Now, they made these two separate species. They were the same species until 1774, and they made them into two different species. Actually, the polar bear and the brown bear, they can mate successfully and produce viable offspring. So really, they're the same species. But because they're so different looking, and because they live in different environments, they name them two different species. So, they're both in the same genus here. Do you understand? We go from, if you look at the taxonomy of everything, the animal kingdom includes all the animals, and then that's divided up into the different phyla, and there's several different phyla. There's about 40 different phyla of animals. Bears fall in the phylum Chordata, and then they fall into the class mammals, and so there's lots of mammals, and we fall in that class. And then there's the carnivores, and then the family level, which includes all the bears and the pandas, and then finally the genus that's strictly just bears. Y'all see that? Okay. And so the brown bear is Ursus arctos, and then we have a polar bear in there as well. So these are really closely related. They can actually interbreed with each other. And that's important for me to show you that because of what I'm going to be seeing as we go along. Now they think the earliest fossil they find from the polar bear is supposedly 100,000 years old. Branched off from the brown bear, it's lighter in color. So in the northern regions where there's snow, it's less visible and not as visible to predators. More resistant to cold, and it's adapted to the sources of food in the Arctic region. So each one of these characters that it has, which is different from the brown bear, gives it an advantage in that particular environment. Does that make sense? Yeah. So it has an advantage in that environment. Now then, so what happened? What happened with the polar bear? How did it come to arise from the brown bear? What was going on in the bodies of these bears that allowed them to survive more in this really extreme climate up there? It's only been recently that we've been able to check that out. And so, here's what happened. There was some mutations that occurred in this gene, the APOB gene. Now that gene is involved in your metabolism and how you eat foods and how you metabolize those foods. We have the same gene in humans, and it works almost the same. Now the diet of bears, they eat lots of seal blubber. That's what they do. Lots of fat in their diet, and they're able to exist and do really well. In humans or mice, if we have a mutation in that particular gene, high level cholesterol and heart disease, we have them. But with the polar bear, it works okay. He can eat lots of fat and it not mess up his metabolism. Isn't that interesting? So, here's the deal. In the polar bear, there's multiple mutations of that gene, and that's where it's now able to eat lots of fat and not have any cholesterol problems or heart trouble. What they have found in research is the mutations were damaging. The protein, its function was destroyed. It's a broken gene. Same with the second gene, LYST, that is responsible for coat color. It's a broken gene. So the brown bear and the polar bear, they were one species, they were all brown, but then a couple of genes broke, and that made the black bear. But that was an advantage for the black bear to live in the northern climates. Does that make sense? So it's a broken gene, but it was a beneficial mutation. So the mutation is beneficial, but it's broken genes that cause that. Now this is why this is important, because evolution is always assumed we've got these mutations, and when these mutations occur, that brings a new trait, and that brings new genetic material. But now we're finding out it's not new genetic material, it's broken genes.
What does that mean? Can you explain?
Yeah, okay. Let me explain it like this. Bacteria. They think that was the very beginning organism in evolution. Bacteria in its DNA has about 1,000 genes. You go all the way through evolution and come to us, in our bodies, we have a whole lot more DNA, and we've got about 50,000 genes. So to go from 1,000 genes to 50,000 genes, you have to add genes to the DNA, right? And so evolution has been assuming all this time that whenever a new trait arises, it adds more DNA, and that DNA is beneficial. And then with evolution, as it goes through time, it stacks all this new DNA up and gradually increases the DNA and brings new traits to organisms. Okay? Does that make sense? That's what was always been the assumption in evolution. We've never been able to test it. Well, now we can look at the genes. And what we're finding is every example they give us to show evolution is occurring, it's not adding new DNA material. All it's doing is just breaking a gene in one organism to make the second species. Does that make sense?
I'm just wondering what breaking it means.
Okay, when you have a protein that's got a particular function, if the DNA mutates, it doesn't put that protein together right, and so that protein cannot fulfill its function of converting one chemical to another. So it's a broken protein. So this is really cool. This is just one of the greatest things that we've come across. And I know it doesn't seem great to you, but in my world, this is just wonderful because evolution's always assumed we're making new genes, but in actuality, every example they've given us, it's a broken gene that makes a new organism. So that means when God created everything in the beginning, He created everything with all of its DNA, and the organisms that's arisen after that, like the polar bear, that came about by just one of the genes breaking, not making new DNA.
Would that be like the dog species? How one dog quickly?
I'm about to tell you about those. There's one of my examples. Yeah, that's coming up. Isn't that cool? That's a problem for evolution. They've always assumed we're making new DNA all along to make organisms. No evidence of that now. It's only been broken genes. Yeah.
Could you say it's a deformity?
Yes. Mm-hmm. It's a deformity of that particular protein.
Right.
Yeah. Not a structural, physical deformity, but a physiological deformity. Yeah. That's what it is. And that's how the new species came to be. Yeah.
So, I have a question. So,
yeah.
When the gene breaks, right? Is that,
yes.
Okay.
Mm-hmm.
Does that happen, right, because of something, its surroundings, its environment, right, makes it do that, or is it?
It just could be. It happens. Yeah. Whenever an organism duplicates itself, like a bacteria, whenever it's reproducing and makes another bacteria, it's got to duplicate its DNA. It's got to make an exact copy of every bit of its DNA. And making that copy, sometimes there can be mistakes in there, and that's how mutations.
So if it happens, like for the polar bear, let's say,
yeah,
whatever gene broke,
mm-hmm.
get white, and so it can eat more fat, and all
right.
that was beneficial to it. But sometimes genes break when it won't be beneficial.
That's exactly right. That's exactly right. In fact, most mutations it is not beneficial, but every once in a while, a beneficial mutation occurs, and it allows for a new species. In this case, it's a pretty obvious new species. I mean, completely changing color, had to change its environment, move north, and that happens. But most mutations are pretty harmful, and hurts the insane.
So if I'm understanding correctly, you're saying the mutation or the breaking of the protein is not always environmentally driven.
That's true. It could be just when it's making the DNA. Now, some mutations are environmentally driven. Certain chemicals can damage your DNA.
Right.
And so that happens as well. Yeah, very good. Well, you are pretty smart. That's really great. Yeah, y'all should be scientists. Now then, the altered genes had several mutations. In those two genes, there were several points of mutation in there. And then they adapted to that harsh environment. And so it's broken genes that made the new individual. And that's just really, really kind of interesting. We see the same thing in humans. Sickle cell gene. That is a really simple, one base change in the DNA, but it makes the red blood cells sickle-shaped instead of round-shaped. But in Africa, where they have a lot of malaria, that's an advantage. But it's a broken gene. It's a broken gene, but it's an advantage for these individuals in Africa. So that's how new traits arise, but it's never making new DNA. That's interesting. The Okatuk gene, that it relates to the pigment melanin in the irises, and it causes, when it breaks, blue eyes. But blue eyes is an advantage in some cultures. And so, but it's a broken gene. No new genetic material. And so, damaging mutations result in beneficial traits. Now, evolution's always been saying along, here's a new trait. And so we're gradually building new traits in organisms. No, we're not. We're breaking the DNA to make these new traits. And that's really a good thing. That's a problem for evolution, okay? So now we can measure this with our new molecular techniques. What we see in the literature, all Darwinian evolution processes proceeds mainly by damaging or breaking genes. And that is a big problem for evolution. Now then, Darwinian processes only account for small-scale adaptations only at the genus species level. Evolution has never shown us going from a genus to a different family. They can't show that. They never have been. All your examples in your textbooks are down here at the genus species level, and they're showing just at the genus species level. They never can show an example where it's switched to a different family. And the reason is because it's broken genes that's causing it. It's not making any more DNA, and that's really fun. Now, once the damaged gene is there, and it is a beneficial mutation, it usually puts them in a specific environment. Like the polar bear, it's now limited to the northern areas where there's snow. It's very limited to that environment. If a polar bear came down to the mountains of the Appalachians, it's white, it'd be very obvious, it'd be very visible to predators, and it wouldn't last. So it's very limited in where it can live. And that limits how much it can change anymore. It usually can't change anymore after that. So that's how it's working with all of that. So we now know the mechanism, and that's just really, really cool. So it's only at this genus species level can evolution show any kind of changes, but those changes are always broken genes. And that is a great thing to see. Now then, Darwin's finches. You remember all the finches out in the Galapagos Islands of Darwin over there? Yeah, there's now different colors there, different sizes, different beak sizes as well in all these. They divided them up into 4 groups based on where they eat. The ground finch, the tree finch, the warblers, the vegetarians. And there's the Galapagos Islands right there. There's the Galapagos Islands. So he traveled on the ship all the way down here. His job was to investigate all the plants and animals here in South America. Then they traveled around, and that's where he got his idea of evolution with all of these finches that had the different beak sizes. They actually measured, Peter and Rosemary Grant went to the Galapagos Islands and measured every bird on Daphne Major. That's the island that they were working on. Every bird. They knew everything about every bird. They measured its beaks. Yeah, they went and measured all their beak sizes, their colors. They even kept track of what bird mated with what bird and looked at the offspring. They kept track of everything on there. And what they found, and this is in a biology textbook, what they found in 1976, the average beak size was about 8.8 millimeters. That's the size of the beak. The offspring in 1976 was about 8.8 millimeters. Beak size was about the same. Then a drought occurred. When the drought occurred, all the small plants died because they didn't have very deep roots. The large plants, which had deep roots, were the only ones that were able to survive. Well, the large plants had big seeds. And so those birds that had little bitty beaks had nothing to eat, they died. And so average beak size in 1978, 2 years later, went up to 9.8 millimeters. So the population evolved. It changed. That makes sense? Yeah. So that's what they show you in the textbooks. This is from the textbook, and it says you can see the population changed in this trait. It evolved. And so I would say, yes, it did. It evolved. And it's mainly evolved because all the little beaks died. And so there are mainly only large beak birds left. But that's how we look at evolution. You say the population evolved with all of that. Well, I went and looked at their data. After seeing this in class, I went and looked at their data. And there's beak size. Yeah, it did go up. Beak size went up. But then it rained. The small plants came back, and the average beak size went down. Then there was another drought. It went back up. And then it rained again, and it went back down. And then it went way down. And it stayed down for a long time, went way down again, and then went back up with another drought. So it really never changes over time. What they want you to see is this, and they'll say, see how beak size is changing? The population is changing, it's evolving. Well, we know now in most situations, things just go up and down, but it never really changes. It never really changes over time. Does that make sense? Yeah, so if you check out the data, you'll find out the real story. Now then, when they investigated the DNA on these finches, guess what? They concentrated on these master genes, and particularly one was ALXI, was the gene they looked at in detail. Now that same gene in humans causes severe birth defects in the head and face region. So when they were looking at the different types of blunt beak or pointed beak finches, they were looking at this particular gene. Guess what they found? A broken gene. The difference between those two birds was one had a broken gene. There were 2 out of the 326 amino acids that made up that protein that mutated, and both of them were classified as damaging mutations. And so the difference in the two organisms, it did look like they evolved, one into pointed beaks, one into blunt beaks, but it was because of a broken gene, not new genetic material. Does that make sense? Darwinian evolution wants us to think new genetic material is being made all the time. And it's not. It's just the genetic material that God created at the beginning just broke. That's what's going on. Is this making sense to you guys?
Yep.
So it's just wonderful. I teach genetics as well, and this has just made my heart jump after I found out all this kind of stuff. So it's only changes up here at the genus species level. The African cichlids, man, the cichlids are a fish. They have a particular body plan that's just kind of the same body plan. We even have some of these cichlids in Texas, and that same body plan is with them. Now they say new species arose in Lake Victoria, and it's publicized not only in biology textbooks, but in the media as well. Spectacular evolution. All these new species of cichlids that have come about in Lake Victoria. And what do you think caused it? It was changes in 2 regions of this gene right here. One region binds another protein, and the other is a region that's modified after that protein is break. Both of them, the abilities by that protein is lost. It's a broken protein. And that's what's causing it. There's 4 different genes. There's about 4 different genes in the cichlids. And this guy reported it's just 4 genes, and it's just broken parts of that gene gives the different types of cichlids. And so all the variation is just from different broken genes. Isn't it not fun? That's just fun. Now then, the greatest evolution experiment ever. There's a researcher, Linsky, up in Michigan. He started out with these beakers of bacteria, E. coli, in fact, E. coli bacteria. Now, E. coli, they reproduce every 20 minutes. So one E. coli, which is a bacteria, it's a single cell, it'll reproduce itself every 20 minutes. So you can go from one E. coli to millions in a day, okay? So he started out with these flasks, 12 flasks. He had E. coli in these 12 flasks, and he let them grow for a whole day. And then the next day, he would take out 1% of the bacteria in that flask and put it in a new flask and just let that go. Changed it every day for 25 years. He's done this. Is this a long experiment? It is a long experiment. Every day, They just take out 1% and put it in a new flask, and that's the new population. So they're looking at this population of bacteria over time to see how it evolved. And it did. It evolved. It got, let's see, right, yeah, 65,000 generations. Is that a lot of work? That is a lot of work. And they kept tracking about every 500,000, or about every 500 generations, they would save those individuals and freeze them so that they could go back and look at them later. So they kept track all along the way of all these generations. Yeah, they'd freeze them and store them. Now then, after 1 month, they started growing faster. They started multiplying faster. After 2,000 generations, the growth rate was 37% faster in these flags. So there was a little variation among the 12 different lines, but they were growing faster. And then after 50,000 generations, the growth rate was 70% faster. These guys were just multiplying really quickly. So it was changing. Also, they were getting fatter. They were 85% increase in size. So the bacteria were getting fatter and they were multiplying quicker. The population was definitely evolving. That's what, there's no doubt, it was changing, it was evolving. Now then, they looked at the DNA analysis. The evolved cells lost the ability to metabolize ribose. The protein that broke down ribose broke. It was a broken protein that caused that. It wasn't that they were gaining new genetic material along the way. It's just a broken protein. And it was a beneficial mutation for them to do that. So more mutations were tracked in this experiment, and every one of them were broken genes. Isn't that amazing? So evolution was occurring, but it was just because a gene broke, and that's what happened.
They have 12 flasks,
Mm-hmm.
and the same gene breaks in all 12 flasks?
Mm-hmm.
That's weird.
That's really confirming that there's certain genes that break in organisms that might give them an advantage.
It would make sense if it broke in one, but not in all 12.
Well, yes, if you had a short amount of time, but when we're talking 65,000 generations, and in a population that big, I mean, each flask would get millions of these bacteria. And so the possibility of that same gene broken is really high. Yeah. Now, some of the other genes broke, but those individuals died. That's what Eden was referring to. Some of them are not beneficial mutations. But every once in a while, a broken gene gives a beneficial mutation, and that's what happened.
And they were using the same one to grow the next, right?
Yeah, they
So
kept,
they
this
didn't
line
like-
stayed its line, this line stayed in its line, yeah. Mhm. So it's really interesting. It just really shows that in evolution, it's only a few things that change. And it's always by a broken gene. It's never adding new DNA material. Isn't that cool? For a scientist, that's really cool. It's just not really cool. Yeah. So, yeah, just really, really fun. So what can we conclude of all these lab experiments? It's always a degrading or destroying the protein. It's always a broken protein that's causing these things. That's just really interesting. You know, there's thousands of ways to break a gene, only just a handful of ways to improve the gene. And so it's easier to get a damaging mutation. And that's why you always see the damaging mutation. It just happens. Okay, beyond that, I'm getting to the dogs. Beyond that, look at horses. Some horses trot smoother than other horses. Have y'all rode a horse and it's really bouncy? But then you get on a horse and it's just really smooth. It's one gene. It's just a single mutation in the gene in the nervous system. But what happens to that gene? A third of the gene breaks off. And then that makes the horse run smoother. It's not a new gene. Well, it is a new gene. It's a broken gene. But it's not a new genetic material that makes him run smoother. Now, when they advertise this, they just emphasize how the trait was controlled by one gene, giving us the idea that it added new genetic material to this horse. But it didn't. It broke a gene. And it broke one of the gene's functions. And that's how we got this new trait. Isn't that interesting? I just think that's so interesting. In humans, 2014 New York Times, there was an article on people who were now immune to developing diabetes. Guess what happened? It destroyed a gene used by the pancreas for insulin making. A broken gene, but that's an advantage to not get diabetes. Yeah, so they're not interesting. In Europe, 9% of the people in Europe are resistant to HIV. You know how they got resistant? A broken gene. There's a broken gene on our immune cells, and the HIV attaches to these cells and gets into the cell. But when that gene broke, they weren't able to attach. And so now HIV can't get in their cells because of a broken protein. Every new trait is a broken protein. Yeah.
This may not be a very smart question, but
Yeah.
I'm asking it.
Ask it.
So the gene that's broken, does it break when it first is folded,
made. Mhm.
or does it break after it's already folded?
It's usually, it breaks and it doesn't make right. So as it's being made, there's a broken part, so it can't fold correctly.
Okay,
That's
but
what happens.
if a gene ever folds correctly, does it break ever afterward? Is there any possibility of that?
Yeah, there is a possibility of that, yeah. In fact, we saw that earlier on that gene in the bacteria.
Oh,
That had two regions that break. One as it's being made, and then one
all right.
after it's made, it breaks after that. Yeah, so that does happen. Yeah.
Yeah, I've got a question on that horse. The broken gene that causes the horse not to have
A bouncy thing, yeah. Mm-hmm.
There have been horses that, when they have been gotten and raised by owners, that they had that horse rod and they want to put them in some kind of competition or whatever. They train them to where they do ride more smoothly.
Yeah.
Is it because they somehow that
Yes.
gene does break off, or
Yeah.
they just begin to overcome that disability?
They're just able to overcome it. They're able to use their own physical strength to overcome that. Yeah, which is what you and I do a lot of times, you know? We can, I get really nervous sometimes, and I can be really itchy, but I've learned to control that and be still, you know, that we can do that. You can overcome
So,
something.
but that's not a broken gene, that's just,
That's just your body, you're managing your body in a certain way, yeah. So there is that as well. Have y'all heard of antibiotic resistance in bacteria? Yeah, so here's a bacteria cell. It has a protein here, and that's what the antibiotic attaches to get inside the bacterial cell and kill it. If you break that protein and it's not gonna be there, then there's no way for the antibiotic to get in there. It's a broken protein, but it's an advantage to the bacteria. They're now resistant to that antibiotic. So isn't that interesting? Yeah, they've always said we see evolution occurring today because now we have bacteria that's resistant to antibiotics. It's evolving. Well, yes, it is evolving, but it's by a broken protein. It's not changing into anything else. Does that make sense? That is so fun.
So
But
that
that's-
has nothing to do with whether you take all your antibiotics or not? They say take them all or.
Yeah, you need to take all your antibiotics to make sure you kill all the bacteria. If you just take a few, you might damage a few of them, and then they may mutate by breaking a gene and then become resistant.
That's what I.
yeah.
Yeah, so you take all your antibiotics.
Resistance so much comes from taking genes.
Yes, because y'all know chemicals can cause mutations.
Yeah.
And so if you just break it a little bit, they become resistant. Yeah, you need to take all your antibiotics. Yeah, that's the way that works. Okay. In 2014 New York Times again, mutant gene APOC3, substantially lower cholesterol levels, shielding them from heart attacks. Protects people from having heart attacks. But again, 4 mutations destroy the gene's function. It's broken protein. It's not new genetic material. So, very often the quickest way for Darwinian evolution to mitigate a problem is to break a gene, and that's how evolution occurs. Dogs, where we at? There's our dog breeds. Increased muscle mass, it's degradation of the myostatin gene. Yellow coat color, loss of function of that particular protein. Black is due to deletion of a glycine residue from beta-defensin. Coat furnishings such as long or curly hair, it's due to mutations damaging 3 separate genes. Isn't that interesting? All these new dog breeds that have these new traits, it's because they have broken genes. In fact, the dog breeds are getting so broken, it's hard to keep the breed going anymore. And so they're just getting worse and worse and worse. And to come up with a new trait, you have to have a broken gene. Isn't that interesting?
Is that coming from our manipulation of it? Because they're trying to make better dogs by interbreeding them and trying to force changes.
They're trying to make new breeds of dogs,
Right.
but what actually is happening is they're looking for a different broken gene. They don't know it. They're just looking for a new trait. And when that new trait arises, they try to keep that trait going, but the dog is actually very limited in its physiology and doesn't do very well. So most dog breeds are struggling to stay alive. It's all broken genes. Yeah.
Dogs evolved from the wolves.
Yes.
Well, who did the wolves mate with to create dogs?
A broken gene.
Okay, now I don't know the dog kind. I'm not sure what God created at the beginning. Now you and I want to think it was a wild dog that God created at the very beginning. I am not sure. It was a dog kind. Now from that dog kind, we have wild dogs, we have coyotes, we have the few dog breeds and everything. And so I don't know what was at the beginning. You and I want to think it was the wild dog, but we don't know that. We really don't know. A wild dog may have arisen from the original kind that God created. I don't know. Does that make sense? Yeah, we make a bunch of assumptions on our side. We make a bunch.
It just comes from the original wolf.
What are you saying he doesn't know?
I don't know. I don't know. It was some kind of dog kind that God made. We don't know that kind. Yeah, we just assume it was a wolf or something in the wild. Yeah, we just don't know. Other dog things. 6 different genes control the variation in size of dog. 3 of them involve degrading changes in the protein coding region of the gene. The other 3 have tweaks in the control gene that lowers the amount of protein, so it reduces its amount of production. And so that gives different sizes of dogs. Short muscle is associated with mutations of these 2 genes, and it lessens their activity. It shuts down their activity. So, and everything about dogs, even the friendliness of dogs towards humans compared to less friendly wolves, it's associated with the disruption of these 2 genes, GTF21 and GTFRE1. It's breaking genes to make them more friendly. And in fact, disruption of these 2 genes in humans, it leads to outgoing personalities and mental disability. Isn't that interesting? So all these outgoing people around here got a broken gene. Yeah.
I saw a documentary on making foxes docile, and they're doing that by interbreeding them, and they'll take one that happens to be less aggressive,
Okay.
and they'll try to breed that one, and then they'll be less aggressive,
Right.
because there was this push to make foxes domestic,
Yes.
which in their natural state they're very hostile.
Right.
And so that very thing that people are trying to do.
So they're trying to mate with this fox that has a broken gene.
Yeah, yeah.
Isn't that interesting? It's always a broken
So
gene.
they're trying to recreate the broken gene.
Well, they're trying to breed with
Maintain
that
it.
broken gene. So they find an animal that has the broken gene. They don't know it's a broken gene. They just say, we have this animal with this good trait. And so they try to breed for that trait and
That's
select
like
for it,
dominant
select for it.
recessive traits.
Yeah, it could be a dominant recessive thing, yeah. So, but it's really interesting. All these traits that are beneficial, they're broken genes. Isn't that interesting? Yeah. So I think y'all got my point this morning. So their greatest problem, most of all beneficial mutations are broken genes. The more genes that are degraded, the fewer available for future adaptations. Once you break a gene, that organism is very limited on where it can live, and it can't take very many more broken genes to survive. And so it's usually just a few broken genes, but it causes a beneficial trait. And so natural selection can only work at the gene of species level. You never can switch to a different family. That's like going from a cat to a dog. We never can show that in biology. You can't show evolution occurring that way. The only way they can show evolution in natural selection is with a broken gene. Isn't that interesting? So that brings me to this. Not Genesis 1, but Genesis 2. In Genesis 2, the first 3 verses, thus the heavens and the earth were completed in all their hosts. By the 7th day, God completed his work which he had done. And he rested on the 7th day from all the work that he had done. Then God blessed the seventh day and sanctified it, because in it he rested from all of his work which God had created and made. Every bit of that DNA was made when God created everything. It was all made. It was done by day 7. How things have evolved since then, it's just been small changes in the species level, but it's by broken genes.
Would you call that adaptation?
I'm sorry?
Would you call that adaptation?
Would you call the brown bear, because of these broken genes, getting white fur and being able to eat that and moving to the north, would you call that an adaptation?
Yes.
That's adaptation. It's broken genes.
What about the difference in sizes of animals, like the dog to a great day? I mean, is broken genes cause all that?
Broken genes are causing all that. The different sizes, we saw the different sizes, were several broken genes. They give the different size. Isn't that amazing? It's not new genetic material, and that's what evolution wants us to think.
Has all this new discovery occurred since we mapped the genome?
Yes.
All that, so it's very
Yes.
relatively short period of time that we've learned all this stuff.
Yes. I got all this from, did I put his book up here? I didn't. Maybe I put it up here. Did I say it earlier? I meant to point that out. Did I have it up there earlier? I'm going back. Sorry. I hope y'all don't get seasick on here. Oh, I thought I put it on here. Did I not put it on here? There it is.
It's not the cover. just-
Yeah, this came out in February of this year, and when that came out, man, he did a lot of research, and what I just showed you came from this book, Darwin Devolved. Can you reach behind you and pick up that book, Darwin Devolved? Yeah, that's what it looks like. It's just a great book. And this is his third year. Thank you, Dana. Yeah, thank you very much. So, that's just a great book. Now, I've just got enough time here to tell you about one more. Unless you have another question, go ahead and while I make you see something down.
I probably mentioned this, or I don't know if you can mention it there, okay? The broken gene, is that also, is what they're doing when people are starting out to order the babies with blue eyes and, different color?
Yeah, well, once a gene is broken and causes blue eyes, then, yeah, you can select for that trait from then on. So that will be passed on to the offspring. The broken gene will be passed on to the offspring, and so you can select for that. Yeah.
That's not really good, because, that's not, you're messing with us, great.
We're on the same page here. We're on the same page here, yeah. Yeah, they now have a way, this is kind of interesting. For the very first time, last year, the FDA approved using a CRISPR mechanism to correct eye problems. A lot of people are born with an eye problem when they go blind. Well, now they can take this CRISPR mechanism that they found in bacteria. Bacteria used it to chop up virus genes so that the virus would kill a virus if the bacteria got a virus. And so they're taking this out of bacteria, and now they can use it, and it can go in there and chop out the bad gene and put the correct one in. And so now people cannot go blind because of this technology, which it's not a new technology that man developed. It's just a technology that bacteria had that man has modified to do that. And when I heard that, I thought, that's really good. That is really, really nice. But you're exactly right. Now what are they doing? They're using that CRISPR to modify lots of other genes and modify them to make traits that you want. And so, yeah, you and I are on the same page. Yeah. I think I'm pretty handsome. Don't change me.
And I just want something on Ethledard Smith.
I'm about to talk to you about that. Do you know Ethledard Smith?
Yes.
Yes. Ethledard Smith is a member of the church, yeah. And he's a writer. He's a lawyer. And he's funny. He's really funny in his writing. This particular book is called Darwin's Secret Sex Problem. Vanna, you want to show me that book over there?
Vanna.
There we go. I'm sorry, tell me your name.
Monty?
Monty, thank you, Monty. I appreciate it. Darwin's Secret Sex Problem. Now, this is a biology book. He wrote about biology, but he's a lawyer. But he researched this thing really well. He actually researched it for 4 years. the whole book is not about his sex life. It's not that he was having an affair. It's about evolution's fatal flaw. So he's going to say this is evolution's greatest problem. So that's why I'm putting it in here. The origin of sex. How did sex come to be? If we started out as a bacteria cell, a bacteria reproduces just by duplicating itself. But then somewhere along the way in evolution, we had to make a species that had a male and a female. And they had to have compatible parts. And that's a lot of mutations in one generation, because you couldn't get the male first and not have the female, everything would die away. You had to have both male and female made at the same time. And not only did you have to have them made at the same time, they now have to undergo meiosis. Now we're getting some biology terms. Meiosis is where in our sex cells, we change the cell from having 46 chromosomes to 23. We have to have the number of chromosomes so that the sperm with 23 chromosomes and the egg with 23 chromosomes can come together to make an individual with 46 chromosomes. Does that make sense? So not only did you have to evolve a male and a female, and they had to have the right parts that interacted together, you had to have the process of meiosis evolve at the same time. And that's a very complicated process. Very complicated process that takes lots of different proteins to make it work. Do y'all see that? In one generation, you have to have all of that evolve at the same time. And evolution doesn't work like that. Evolution does small, gradual changes over time. And so this is a big problem. He said it this way. How do you get male and female come to be right at the beginning? How do you get this process of meiosis where you have the number of genes all at one time? Now that's a problem for any species. But it has to happen for every new species that arises. You have to have a male and a female that are just right and have the right parts that interact just right. And did y'all know this? Like here's an egg and here's a sperm. That sperm has to have the right pin code to get into the egg. Did y'all know that? There's a protein on the egg, it's a receptor protein, and no other type of sperm can get in there except the human sperm that has the right pin code to match up to that receptor protein. And so there's so many things that have to be involved with that. So for every species, and there's millions of them, you have to have the male, the female with the right parts, everything at the right time. What did I put it up here? The right male, the right female, the right reproductive equipment, the right division of chromosomes, the right pin codes. All that has to be made in one generation. If you don't have it, it dies right away. It's an impossibility in evolution. So he's calling this evolution's greatest problem. How did sex come to be? And he looked at all kinds of books on this. He searched everything, every book he could find on it. Fortunia's book on evolution, it says in there, this is one of the most difficult puzzles in biology. Yeah, nobody can figure it out. George Williams' book, Sex and Evolution, you'd think in that book, Sex and Evolution, they would explain how sex came to be. Not a single attempt is made to explore how sex came to be or the link between asexual and sexual reproduction. Dixon's book, Sex Selection and the Origin of Human Mating Systems, you would think they would tell in there how that came to be. Never addresses the origin of sex. They can't do it. There's no explanation. That's a big problem. That's a big problem with all of that. So, F. LaGard Smith's challenge is this. Let's seek the truth. Let's be open to argument. Even if you disagree, you'll be stimulated to think and investigate, but the burden now is on you, evolutionists, to find the evidence. And they can't find it. They won't be able to find it. So F. LaGard, he's real funny in his writing. He's real sarcastic at times. And so it's a really, really good book. So there's a lot of problems with evolution. You can't go past the genus species level in evolution. You can't make an organism go to another family. That would be like a cat going to a dog. You can't do it. Just never has happened. Listen to these verses. He who planted the ear, does he not hear? He who formed the eye, does he not see? He who disciplines the nations, does he not rebuke? He who teaches man knowledge, the Lord knows the thoughts of man, that they are but a breath. So intelligence has to come from intelligence. To make an eye, you got to be able to see to make an eye. To make an ear, you got to be able to hear to know what you're making. That's how powerful our God is, right? Yeah. Psalms 146. Blessed is he whose help is the God of Jacob, whose hope is in the Lord his God, who made the heaven and earth, the sea, and all that's in it, who keeps faith forever. He made everything. He made everything. Isaiah 40. Who measured the waters of the hollow of his hand, and marked off the heavens by the span, and calculated the dust of the earth by the measure, and weighed the mountains in a balance, and the hills in a pair of scales? Have you wondered that? Why all the mountains are where they are, and how the earth rotates and doesn't wobble? You know, if they did this in China, they built this huge water dam, and it built up a huge amount of water behind this dam in China. It changed the rotation of the earth just by a teeny tiny bit. But God calculated how everything needs to be placed on this earth so that it can smoothly run and not wobble as it's spinning around. Isn't that interesting? So even in that China thing, when they built that dam, it changed our rotation just a little bit. I forget, it's like 0.15 second or something like that. It changed our rotation when they built that dam and all that water built up. God's got everything calculated just right on this earth. Wow. Have you not known? Have you not heard? The Lord is the everlasting God, the creator of the ends of the earth. He's just not faint or grow weary. His understanding is unsearchable. Jeremiah. But the Lord is the true God. He is the living God and the everlasting King. And at his wrath the earth quakes, and the nations cannot endure his indignation. Thus shall you say to them, the gods who did not make the heavens and the earth shall perish from the earth and from under the heavens. It is he who made the earth by his power, who established the world by his wisdom, and by his understanding he stretched out the heavens. Oh, I'd like to talk to you about the heavens. Do you know how the stars got to where they're at? It's kind of an interesting thing. Huh?
I said, you go there.
He stretched out the heavens. Did y'all know it says that 17 times in the Old Testament? He stretched out the heavens? Yeah. There's no way science can measure that. There's no way you can measure that. How God can do it. Jeremiah. Ah, Lord God, it is you who made the heavens and the earth by your great power and by your outstretched hand. Nothing is too hard for you. And then lastly, in the New Testament, we've got this. By faith. You know the faith chapter is Hebrews 11, right? Y'all know that. The first one mentioned, by faith, we understand the universe was created by the Word of God, so that what is seen was not made out of what is visible. All he had to do was just speak it, and it happened. He made everything complete. Yeah, it's evolved since then a little bit, but just like broken proteins and just small changes. But that's it. Evolution is only just a small part of all of that. Are we okay? Okay. Questions? Yes, sir.
It's true that the heavens are continuing to expand. Isn't that right? The stars and the universe continue to expand.
According to Einstein and other people who are watching that, and it looks like the planets are going away from each other, but recently, you know, it's hard to measure things billions of years away, you know? So you gotta let the Earth get on this side of the sun and measure it over there, then let the Earth travel to the other side of the sun and then measure it from this angle and do triangulation on that to see how far away it is. But can we measure that really? There's now research saying, no, they're not moving. Because they're using a different method of how to measure that, and they're not moving.
I was wondering if it's expanding, what is it expanding into? If I have, yeah, it's gotta be something on the other side of that wall.
Is there a wall? I don't know. I don't know. God is it's just a vast universe. We'll never be able to understand it. I'm not sure we can measure it though. It's hard for us to measure way down here on Earth all these planets and galaxies that are out there.
So after listening to everything this morning, it just kind of reiterates to me like Noah and the ark and having the certain times and then how we can have so many times relatively not as much.
Yeah. Yeah,
Change.
that's exactly right. So we had a cat kind, and from the cat kind we get the tiger, the lion, the domestic cat. And we just do that by selection. It's probably been broken genes that make all the difference. Isn't that interesting? Just really interesting. We serve a great God. Yes, sir.
Yeah, have they explained, what is that black hole that they said that form that appeared?
Yeah.
Wasn't it supposed to be bigger? What,
I'm sorry, I am not in astronomy. I don't know any of that kind of stuff. Yeah, it's a black hole in my brain too.